Lesson Recording Manuscript by Miguel Gonzalez, EDT 630, Multimedia Design and Development, St. Thomas University, Dr. Gary Ackerman, March 8, 2017. Hello students, as always your teacher Mr. Gonzalez has the pleasure of working with you today. So with that in mind, today we will cover the concept of area. We will use the ideas of similarity, geometric transformations, symmetry, and drawings to discuss math sequences that are applied in the real world. In particular, we will focus on scale factors of two-dimensional figures to demonstrate proportions and changes in surface area. Before we get started, let us cover the math terms you will need to know to ask pertinent questions and collaborate with your peers. Obviously, the first term you need to know is area, which is how much space a figure occupies. In other words, we can think of area as a blanket that you cut in a particular shape that will cover that particular object that you want to cover. Area is dependent on the shape you choose to work with. For instance, a squares and rectangles area is calculated by multiplying the length and the width. The result of multiplying the length and the width is called the product, which is usually factorable by either the length or the width, which is how you can check if it is correct. Luckily for us, both the rectangle and square share similar attributes that allow us to use the same formula to calculate its area despite the dimensions of the square or rectangle not being the same. One such attribute is that both shapes are quadrilaterals, which means both figures have 4 sides and 4 vertices. Another characteristic that is very important to squares and quadrilaterals is that they are comprised of 4 right angles. By this I mean that the sum of their interior angles is equal to 360 degrees, an idea that is fascinating and crucial in geometric postulates and theorems. A key idea that we will precisely be working on is that all quadrilaterals have 4 right angles that must add to 360 degrees. We want to take a moment to discuss why this is so, right? Well, you see, we know that in geometry, quadrilateral means 4 sides. And by construction, we can create quadrilateral ABCD and measure it so that it has 4 congruent right angles. Furthermore, we know by postulate 1 that between any 2 distinct points, there is exactly 1 line. Thus, we can create line segment AB so that it cuts the quadrilateral into 2 congruent pieces. The 2 congruent pieces would be 2 congruent right triangles, as half of 360 is 180. Thus proving the triangle sum conjecture and quadrilateral sum conjecture simultaneously. Moreover, we can verify that the triangles are congruent by using angle side angle side, or side angle side congruency theorems. Now that we know why there are 2 right triangles inside the square or rectangle, let's take a look at the respective formulas. For the area of the square, we know that it is a product of length and width, which can be expressed as s to the second power, or s squared, as each side is the same. However, that is not true for rectangles. As in Euclidean geometry or two-dimensional geometry, all rectangles are squares, but not all squares are rectangles. The reason that all rectangles are squares is because a rectangle can be dilated to be a square simply by multiplying 2 of its sides by a scale factor, whereas a square, that would be a violation of the definition of square, which states that all sides must be of equal length.